But for today's talk, I'm going to be going through native account abstraction and ZKsync and how we implemented it, what does it mean, and then overall, what is account abstraction going to be like in the future, in the very near future. So I'm going to talk about the past, like what is this idea of account abstraction, why did we need it, and the present, like how did it get implemented today. There are a bunch of different ways that people implemented it, and we did a native account abstraction implementation, talk about what that is, and then finally talk about that future part, which is where the power of account abstraction allows you to do a lot of things that haven't actually been implemented yet. I'm going to talk about some of those things and what ZKsync is working on to sort of push things forward and what things could look like before the end of the year. So, starting off, what is account abstraction, right? But to be able to answer this, I need to give everyone some context, make sure you know what is a smart account. Now, to be able to give you context on that, I need to go a little further, like why not a blockchain wallet, right? And so what do I mean by a blockchain wallet? That's, if anyone's interacted with Ethereum or a blockchain, you have to start with a wallet. And to be able to create a wallet, you basically go to some service or you have an application running locally that whenever you create an account, it gives you a seed phrase, like a 12-word phrase that you have to write down, because if you lose it, then bad things happen, right? You basically cannot recover your account at that point. So you are stuck in a similar scenario where you have to remember these 12 words, and if you don't, then your account's lost. Good luck, right? That's problem one for this traditional blockchain wallet. So that's why not part one. Another part is it is very easy in today's world, as you've probably seen from all over the news, to get scammed in the world of blockchain. Meaning you are basically one click away on a bad website from losing all of your assets on your wallet. You can lose all of your tokens, you could lose your NFTs, you could lose just general access. So you have companies like MetaMask who are starting to try different ways to prevent this by just showing you warnings, right? Like, do you know what you're signing whenever you approve something on your wallet? Are you sure this is actually supposed to be doing what it says? But these warnings, they're coming from the MetaMask company. They have this text file that they just update constantly in GitHub that say, hey, these websites or these contract addresses, they're bad. They're malicious. So you're kind of just relying on them, or they bring it to another third-party company like Blockade to bring in this extra analysis. But at the end of the day, if you were to sign this and they didn't catch it, you're essentially just one click away from losing everything on your wallet. So those are basically why not a blockchain wallet. That is a big blocker, and it's really scary to the point where people are not comfortable right now putting all of their savings into blockchain, into a wallet, right? People are scared about that right now. You see these stories of how easy it is to get scammed or rug pulled. So let's talk about what a smart account is. Now that you know this, a smart account is basically a programmable and easily configurable wallet that is essentially a smart contract that looks like a wallet, right? And there are it introduces a bunch of different capabilities, like different ways to authorize transactions. You can have this idea of different backup keys or social recovery, meaning you don't have to necessarily be 100% out of luck if you lose that 12-word passphrase. The big question is, how do we initiate a transaction once you live in this world that a smart contract is actually your wallet? And that is account abstraction. So with account abstraction, that is where you get the ability to send transactions. You can pay fees with your balance, and even further, you can have someone else pay for your fees for transactions. So that is called a paymaster. And that is something that you get with, I'll talk about that a little more later. But this all sounds great, right? This is much better than these typical wallets that you've had up until this point where you have to memorize that passphrase, the secret. But where's the catch here? Why doesn't everyone just have account abstraction right now? And there's so many EOA wallets and like, why haven't people migrated over yet? And really, one of the big issues, if not the biggest issue, is retention. So there was this post from Jared Watts, who's an amazing devo, that he sort of describes the problem as these smart contracts are being developed by app developers for each application. Meaning, if someone tries to use that smart contract wallet outside of that app, it's probably not going to work. And furthermore, this leads to a massive retention drop-off. So the analytics that someone has run basically showed that after 1 week, most people are, 99% of people are not coming back to that wallet and reusing it. So you are just basically distributing your assets to things that you 100% forget about and never come back to. So this idea that you previously had a wallet that you could use on any website, that it just puts all your funds together and makes it easy to transact with things on chain, it has gone away now. Those benefits are no longer there like you thought they were. But this is where native account abstraction comes in with ZKsync. Yes?
Were they stats the regular wallets?
These, no, this was the smart contract wallets.
Right, okay.
Yep. So, and anyone feel free to ask questions. I'll also have a section at the end for deeper questions if things come up and you don't remember. Native account abstraction on ZKsync. So, on ZKsync, we sort of solved this problem by doing one major thing, and that is all EOAs are smart contracts. So on our network, on the L2 in Ethereum, we basically treat every EOA wallet that you previously had as a smart contract underneath. It is not just, it has very basic logic, and I'll get into what does that even mean, but we took this approach and it opened up a whole bunch of things. So the way that it works is a transaction will come into ZKsync, and it doesn't have to come directly from a wallet. Now, whenever it hits ZKsync, we have our system contracts. So we have the main one, which is our bootloader written in YUL. The bootloader will take a look at this incoming transaction, and what it's really going to do is it's going to send it to the address in the from field of the transaction. So it looks at the from field of the account, but this is where the bootloader sort of makes a decision. It looks at that from address and sees, oh, is there any code deployed there? If there isn't, then we're just going to treat it like an EOA wallet using this smart account, this smart contract called default account.sold. And yes?
What's an EOA?
An EOA is externally owned account wallet. Right. So basically, the normal wallet that you've had up until this point, where you fully own everything about access to your wallet. You have the private key. You have the seed phrase, right? The other approach is, the other option here is, what if it looks at that from address and there is code deployed there? Then it's just going to use that account's code, right? So the purpose of this default account contract is so it just emulates an EOA wallet. What exists today in Ethereum and pretty much most chains. It's just going to do that and be happy about itself, and you will never know. But it's not. That's when we get into using accounts code. So what do I mean by that? Well, as I go into this, I want to talk about sort of two things that are necessary. This is where I start going into like more of the code stuff. But there are two interfaces that we expose that any developer can sort of access. I mean interface from like a Solidity contract or like a developer standpoint, right? So if you see like an I, a capital I in front of a contract, that's interface. The first one is account transaction execution. So it's important to understand that there is an agreed upon interface that ZKsync has for defining how account transactions should behave. And then a second one is for paymasters, the iPaymaster interface. This is here so that we can standardize how people can pay for other transactions that they don't necessarily own. And I'll get into some examples of what that means. But by having this, what you're essentially doing is putting everything behind this ZKsync sequencer. Behind, we are saying that it is a standard on our network to have these abstract accounts, to have these paymasters. So multiple apps will basically be reaching out to ZKsync, the sequencer, which ultimately can reach out to your smart contract, and this is going to be implementing that iAccount interface. So it will just, they will both understand and have full access to these smart contract accounts for free. These app developers who make apps, they don't have to worry about that same problem that I was talking about before with retention. It's just always available. Every account is a smart contract on ZKsync. So, what does this magical interface do? It's basically three things. It validates transactions. It then decides who's going to pay for that transaction, and then it will execute that transaction. And looking at some pseudocode, basically, this is how inside of that interface, these are the functions of the method signatures inside of there, which is you validate transaction. Then inside, this is where the decision comes in of who is going to pay for that transaction. If you declare that in that transaction, you say, hey, this transaction should be paid by this other contract because I don't necessarily have the fees to do it, or I want to cover the fees for someone else. So that's a paymaster. And then if you have a paymaster set up for this transaction, you will call prepare for paymaster and then finally execute the transaction. If there was no paymaster and you need the user who submitted that transaction to pay for it, then you just call pay for transaction. Yes?
I wanted to understand, so who makes, is it the smart contract that's making the decision of having someone else pay, or is it the externally owned account owner who's making that decision, and you're just calling the code?
The decision is coming from the transaction itself. Whenever you make a transaction for ZKsync, you have the option of adding some metadata to your transaction as like a dApp developer, right? You can just say, hey, add this little piece of metadata to your transaction that says there's a paymaster, and the paymaster is this contract addressed somewhere else. So one very common example of a paymaster is if for your website or for your application, you want people who have a specific NFT token to not pay anything, not pay fees. So what you can say is you make a contract, this paymaster that exists out there, who has logic that says, oh, if you have this NFT, then use my funds to pay for your transaction.
That's what I'm asking. So the addition of metadata will be by the developer and not by the account owner, right?
Correct, yes.
So what this essentially is, paymaster, it's an account code. It's something that you can call, but can you do that as an owner, or is that something that you can only do as a developer? Like if I wanted someone else to pay, would this code be available to me, or would it be a code that's part of the ZKsync?
How do I put this? It is available to you, but here's sort of the tricky part, is whenever you design a paymaster, this smart contract, the recommendation is always to lock down who has access to that paymaster. And what I mean by that is, let's say I made that paymaster I described before, which says, hey, you have an NFT that says you're a part of Blockchain Scotland. And so for interacting and paying for beers at this one bar, we're gonna cover the price, the cost of it, each transaction that you use. Now, what really should happen is there should be another check in that paymaster that says only that bar should be able to use the paymaster. It shouldn't be just a random account, like you personally trying to access that paymaster directly. It shouldn't allow that. But that's totally up to the paymaster itself. Like we recommend that you add that as part of it. Hopefully that makes a little more sense. But this is all usually like programmatically handled by the application itself that's being developed by the developer.
So, but the application is only in control of like executing the transaction from one way, right? There has to be acceptance from the other end as well. Like for example, the bar also has to accept payment on someone else's behalf through for that it has to have the same system. So is that enabled by ZKsync, or is that something
Yeah.
that is like as part of your interface that is an end-to-end transaction that you can execute?
No, that is handled by ZKsync. So basically, even though the from field of your transaction, like it says it's coming from me, according to the bar, right? Like I am getting the beer. However, it's being paid for by this other account.
Yes.
And so, as far as the bar is concerned, it's still coming from me,
Okay.
and the funds just end up in their account. They don't really care about
Understood.
like all the
So
internals
they
of how
don't
that
need to have a
happens.
separate interface installed to interact with this
Sure.
form of payment.
Yes. Yep. Cool. So that's sort of the present, right? That I talked about. We've had that since the beginning of ZKsync about a year and a half ago. But you know, we can go much further with this. The whole reason for doing this in the first place was to improve user experience, right? To enable this idea that you don't necessarily have to, you know, worry that if you lose your password or your passphrase, your secret words, that you can't recover it. So let's add that little bit in. That if you don't have funds at the very beginning because you just learned about blockchain, doesn't mean that you can't use the chain. It just means, you know, you can have someone else pay for you at the very beginning and sponsor your initial transactions. But there's still more that could be done. So one thing is there is a really annoying Web3 user experience right now. If you have an application, whenever you try and log in, you try and connect your wallet, if you've ever done this, it usually kicks you out to this external application like MetaMask, for example. And to be able to log in, you are basically going back and forth between your browser to MetaMask, back to your browser, back to MetaMask, hitting approve, going back, and doing this until you finally log in. This is super painful, and it rarely works, and it breaks all the time if you've ever like developed a dApp before. This is a huge problem from a user standpoint. Also, I don't know if you can tell, but like if you're asked to sign a transaction to log into a website, authorizing, hey, I'm going to give this website access to my account information, that message is not always clear. Sometimes it just shows up as hexadecimal bytes. People don't read that. Like it's super difficult, and it totally depends. Like this is also only if you have MetaMask. This just happens to be the most popular wallet. There are 50 other wallets, right, that are just like almost getting as popular soon, and you have to support all of them. And hopefully this website can interact well with MetaMask, and then also maybe my other wallet that exists on Base. But it doesn't always, you know, work that way. And if you use MetaMask and you're familiar with it, that's why they have a browser inside of MetaMask to make this a little easier for people. That is super annoying. Another is, you know, if you look at, there's this great thread that was on Reddit, Twitter, a few months back, but this is what gaming on Web3 would look like as a joke, which is everything that this whole game was on chain, anything that updates the game state, you would have to sign off on that transaction. And that just pauses the game, and then it brings up MetaMask, and you can't continue the game until you approve and sign that transaction. This is terrible. This is awful, right? This is like not sustainable. This ain't gonna happen. But how did, you know, auth and games and browsers fix this problem? You know, 20 years ago, they had session keys. They had, you know, the OAuth and JWTs, where basically you give access to another program for a short period of time with limited access of what it can do. This is not a thing that currently really exists too well in the Web3 space, if really at all. It doesn't really have any adoption. So that's why games have, in Web3, just built around this idea that everything you have to do has to be signed and confirmed. And they build the game around that instead of just fixing this core problem. So, in the future, what we're working on is this idea of embedded accounts and session keys. The idea is you basically embed the wallet and you turn your entire app, your website, into a wallet. no more leaving the application. You basically, to create an account or sign into your account, you use passkeys. So if you don't know what a passkey is, that's your fingerprint, that's your Face ID. That is what a bunch of mobile apps have basically moved towards in the past few years for logging into things. You no longer type in your password, you just scan your thumbprint or you scan your Face ID. Also, you only sign transactions when you have to. So there's no need to basically go through and get these constant pop-ups to make progress or to do something inside of an application consistently. What is an example, a demo that we've done so far, is this embedding a tip button directly into Twitter. So what you can do is you can access your account just by giving your fingerprint, right? That's the passkey integration. And then if you just want to send someone money and tip them directly in Twitter, you can actually send it to their account. Your account is tied to your Twitter account. Like your on-chain account, your on-chain wallet is actually tied to your Twitter account. It gets created, and what is the secret phrase? What is the private key? That's your fingerprint. So whenever you send money to someone, right, they can claim it because they also can have an account that exists. They just don't know it yet. If you log in, if I sent you money and you've never, created a wallet before, basically you just log in and then there's a button to create an account right there at the front, and you claim the funds that are associated with your account. To create an account, you just give your fingerprint and there it is. And you can do whatever you want with those new $5 that you just received. So this is a prototype that we did, and we're sort of still working on. But the main thing that we're focusing on is making this easy. This is like an end-to-end test, right, of everything that we've been talking about. But this is great for us because we kind of hacked it together. It doesn't mean someone else can easily copy and paste what we did. So now we're working on an SDK. An SDK so that anyone can add this to their app. So as an example, we have another app that we run at in-person conferences called ZKQuest. And to add something to ZKQuest, let's say there's an existing dApp that already connects to your wallet. Can you just add these new ZKsync smart accounts to it? And the answer is, yeah, it's pretty easy. And this is what it would look like, where whenever you log in, let's say you don't have a wallet or an account, basically it's just going to pop up this gateway, and you click connect, you click approve, and now you're in. Your account exists and it's been shared across. You basically add this other signature to your wallet. And what I mean by that, this is a little more technical, but whenever you use passkeys, like your fingerprint or your Face ID, that is always tied to a URL domain. So zkquest.io or twitter.com or x.com. Each time you save a fingerprint, it is only saved for that domain, only for that URL. So by connecting with your ZK account from a different domain, you're essentially adding two ways to access your account. And why is that actually really cool like behind the scenes? Is you just actually gave yourself another way to access your account in case, let's say, x.com went away overnight. What happened to that wallet, right? That's a big concern. Now that if your website is a wallet, what happens if that website goes away? Well, if you use that same account to log into a different website, you still have access to that same account, and all your funds are still secured. And you have another way, just implicitly, to get to your funds again. So, with this idea of embedded wallets, we pretty much fixed a few things. We enhanced security, and we addressed some UX problems. So with security, we are adding this idea of permission control, so those session keys, but also spend limits. So one thing that you don't see, and I'll get it to in the next slide, is for every website or every app, every URL, you can actually assign a spend limit that you want that app to have access to before you have to sign again or just limit it altogether. UX, so whenever you are in that Twitter demo, that Twitter example, you are not going out to MetaMask, right? To sign a transaction and then come back, right? You are just inside of Twitter and you never leave Twitter, but you're using on-chain assets and you're doing on-chain things. So what does the SDK look like? This is sort of a preview, but basically in your app, right, this is JavaScript, but you just set this new connector and you set a few fields like what is the name of your app? You set what is the session limit, the session key limits, what is the expiry date for every time you are authorizing something. You just say, hey, for the next hour, this fingerprint scan is good. So don't ask me again, just in an hour you can ask me again. And then finally, spend limits. So within this hour, don't spend more than 0.1 ETH, and if you do, I'm gonna have to manually review it and sign it off. But if it's less than 0.1 ETH, just do it and take care of it in the background. Don't even notify me about it. So whenever you log in and you connect with your app to the website for the first time, this sort of gateway pops up telling you all that information. And you click connect. Now the thing is, this is exactly how pretty much OAuth 2.0 works right now. So OAuth 2.0 is that login with Google button, login with Apple, login with GitHub, right? Once you do that, it opens up that pop-up and it says, hey, are you sure you want to grant access for this website to see your Google Calendar, right? And then you just okay, you understand it, you can read it, you understand it, you click connect, you click accept, and then boom, your account is now associated and used for that website for authentication. Same thing here. Imagine that is sort of the way of using wallets instead of having these separate wallet applications that you have to install on your phone and keep the private keys secure, locked somewhere in a safe, and make sure no one has access to, but make sure that someone could get to that safe if you ever pass away or whatever the case may be. So that is the future, I think, for at least the remainder of this year, what we're focusing on about things like account abstraction and just improvements to wallets and user experience in general. That was a lot, I apologize. So any questions, anything you want to dive into a little more? Yes.
So, to which extent does this overlap with this ERC standard for account abstraction? And does it actually work? This standard does it allow different developers to create something that works across different ecosystems?
Two questions there. So I'll address the first one, which is how does this play into the ERCs that currently exist for account abstraction that Ethereum has accepted as a standard? So ERC 4337 is the main one that people call for account abstraction. Now the problem with 4337 and account abstraction in general is no one could really agree. It took 4 years for people to really agree on a standard for how to implement account abstraction. And the reason was because the way wallets were being used when Ethereum was first created was just totally assuming that it would never change. And you would only have these wallets and they would only be these private keys and that's it. Now, ZKsync, because we have our own network, we own the protocol, we made the decision to no, from the beginning, we're gonna have native account abstraction. It's not going to be fully compatible with what works upstream, but that's the case. Now, over the last 6 months or so, 4337 was accepted, and that is a approach that is getting towards the progress of account abstraction. It still can't do this. It cannot take you this far. There are even more ERCs that are being debated right now to get you to this point. 7579 is one that we are interested in because what it does is it takes, you have this idea of a smart contract as your wallet, but to be able to change what that contract does is up for debate. And so 7579 says, hey, we want to create a standardized plugin ecosystem for your smart contracts that says, I'm going to create a smart account, for smart accounts. I want to create a smart account and I want to have a passkey module so I can use my fingerprint. I want to have a spend limit module so I can set spend limits for every app that I'm going to. and I want to also set session keys. I want to add a session key module. I want to also add a deadman key module in case there's no activity on my wallet for 1 year. It gives access to my wallet to somebody else. But it creates this plugin ecosystem. MetaMask has decided to come out with their own ERC for handling this using a delegation system. And it's great, but everyone's just up for debate, and it's just like we're not making actual progress. While meanwhile, people are kind of doing their own thing. Coinbase, similarly, they did a similar approach to this, but they cut corners. They cut corners. Do you see this gateway right here? Right, where it just kind of pops up, and you authorize someone, and that's what creates your account initially. And in the way we designed it, you still own the keys. Your key is your fingerprint that's on your phone or your laptop, right? Whenever you sign it. That is not the case for Coinbase. Coinbase, they did this approach, but they're like, well, we're actually just gonna save the keys and we'll manage it for you. And you're like, whoa, okay. And you can only use their website as their domain. It's keys.coinbase.io. And so if keys.coinbase.io goes away, well, you no longer have access to your funds. It's like your wallet just can't access anything because that fingerprint that you used to sign things was only valid for keys.coinbase.io. So that sort of answers that first part. Second part of your question, how does this help with sending transactions across multiple networks and multiple chains? It doesn't yet. That's a totally different problem. That's called interoperability. The idea that I have funds in Optimism, in Base, in L1 main Ethereum, and in ZKsync, and I want to just treat it as I only have one account and I can easily access funds in between them. That's a different problem goes into like security, and we are addressing that as a totally different thing in ZKsync. But I don't want to dive too deep into that because I want to make sure people have questions about this or sort of understand like our vision of where we're trying to get to. Yes.
So sorry, was there another?
No.
Okay. So it's really cool to see you addressing the real pain points in usability. I was wondering about the trade-offs. So, like for example, is the sequencer is that centralized, or another example could be having these smart wallets. Are you putting more private information on the chain, or is there a bigger attack surface? So these kinds of trade-offs.
Sure. So you're right. If you want to use something like native account abstraction, ZKsync, you're kind of locking yourself into the ZKsync network. For now, the sequencer is centralized, and we should have it decentralized. But I can't give an official timeline, but before the end of the year. That's just something that we're working on right now with governance and things like that. So it's very much happening and a priority for the team. In terms of, does this put more private information on chain? Not any more than you have today, because all it's doing is just replacing your private keys with your pass keys that you save locally onto your device, that your device takes care of managing for you. There's another aspect which says your account has a bunch of websites and a bunch of fingerprints associated that gives access to that account. That could, in theory, expose more information to the point where you could figure out who someone maybe is, but not. I don't know. That's just based off of the different websites that they visit. But that's a bit much. That's a big reach. It's sort of just like if you use, it doesn't change anything like it is today. If you use the same wallet across multiple apps, people can just look at the transactions on chain and figure that out. It's all public information, so.
Well, I guess it can get locked.